Hey guys, how's it going? In today's video, we'll be talking about inequalities in the topic of proofs in Extension 2 Maths. So we've been given two examples. We'll start with the first one. It says let alpha less than beta be real numbers. Prove that the average of the squares of alpha and beta is greater than the square of the average. Second example, if a is greater than -1, show a cubed plus 1 is greater than a squared plus a. Start with the first example. Before we do anything, we need to try and understand what this worded problem is trying to ask us. So it says average of the square of the squares is greater than the square of the average. So straight away in my mind, I'm thinking alpha squared plus beta squared, average of the square of the squares, all upon 2 in this case, is greater than alpha plus beta all upon 2 all squared. We have that in this case. What we're trying to prove is if x is greater than y, x minus y is greater than 0 is what we're trying to prove here. Same thing on this side, we can go LHS minus RHS in this case is going to equal to alpha squared plus beta squared all upon 2 minus, expand the top, we have alpha squared plus 2 alpha beta plus beta squared all upon 4 in this case. Further simplify this, we have 2 alpha squared plus 2 beta squared minus alpha squared plus beta squared, minus in this case, minus 2 beta squared minus 2 alpha beta all upon 4. Correct? This then simplifies as alpha squared minus 2 alpha beta plus beta squared all upon 4. Correct? Further then becomes alpha minus beta all upon 2 all squared. This is what we're getting. In this case, where we can also write this as alpha minus beta all squared all upon 4. It's the same thing. Next step, we know that this is greater than 0 since alpha minus beta all squared is only going to give me a positive number. Hence, this alpha squared plus beta squared all upon 2 is greater than alpha plus beta all squared all upon 4 in this case. So that is how you do example 1. Now we'll go on to EG2. Looking at this next example, it says if a is greater than -1, show a cubed plus 1 is greater than a squared plus a. So to start, before we start anything, write down what we're trying to prove. So to prove x is greater than y, we need to show x minus y is greater than 0. So x minus y is greater than 0. Next thing I'll do is I'll bring all, so I'd rewrite this as a cubed minus a squared minus a, sorry my pen ran out, wait a second. So a squared minus a plus 1 equals to a squared brackets a minus 1 minus a minus 1 in this case. Next step, we go a minus 1. To combine these terms, we have a squared minus 1, so it becomes a minus 1 or squared brackets a plus 1 in this case. So we know that that is going to be greater than 0, and then we develop that a is greater than negative 1. So a minus 1 is, sorry, a plus 1 is going to be positive, and then, so then a minus 1 or squared is also going to be positive. So we then know, therefore, this a cubed plus 1 is going to be greater than a squared plus a. A little different method in equating and proving these inequalities, but yeah, that is how you do these two examples.